Good afternoon, everyone. So today we will discuss about some simultaneous equations in the algebra portion. So we have studied in previous class also the simultaneous equations. So here we have some simultaneous equations like 3x plus 5y equations 3x plus 5y is equal to 12 and 2x minus 6y is equal to minus 20. So we have learned how to solve these equations. Simultaneous equation, this is equation number 1 and this is equation number 2. So as we have already understood that this is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. These are two linear equations in two variables x and y, and while solving them, and we have studied in detail three cases when the lines they intersect each other. When we represent this line graphically, first case when the two lines they intersect each other. In what conditions these two lines intersect each other? When the ratio a1 upon a2 is not equal to b1 upon b2, right? First. Second, when the equation of line, when they are parallel, when the equations are parallel to each other, when we plot the two equations graphically, and the lines are parallel, when the ratio a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the second case, right? a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. And the third case, when the lines they superimpose on each other. These are the only three cases, right? When the both lines they superimpose, they coincide with one another. Both lines coincide with one another, meaning thereby both lines they have they lies on all the solutions of both the lines they are same. In third case, we have this condition a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. These are the three conditions, and in detail we will discuss. First case, the pair of linear equations they have a unique solution. Here it is unique solution where this point like point P, its value of x and y gives the unique solution, right? So today we have again Jaswinder Singh. Very good morning, Bache. Not good morning, it is good afternoon. So welcome you in today's class. Other students also, you are always at least mention your name in the chat box, okay? So that we can have the attendance also. So in second case we have no solution because the lines do not intersect, right? In second case, when A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. And third case, line have infinite many solutions. Infinite, infinite, infinite many solutions. Right? Many solutions. These are the only three possibilities when we plot these equations graphically on the xy plane, right? On Cartesian plane, then three kinds of. First, when the equations they are provide the unique solution. Now, one more terminology that is used when the equations, the pair of linear equations, they have one solution, that is unique solutions or infinite many solutions. The pair of the linear equations are called consistent. What they are called? When we have the solution, these are called consistent. Right? Consistent. Here, case 1 and case 3. Case 1, case 3. We are saying the pair of linear equations, they are consistent. They have one solution, means unique solutions or infinite many solutions. The pair of linear equations are consistent. And when the pair of have no solutions, we are saying inconsistent. Inconsistent. Right? So inconsistent in case of 2. So I have an example here. 3x plus 5y is equal to 12 and 2x minus 6y is equal to minus 12. So we have learned how to solve different methods. We have learned two methods. We have one more method to solve these. One is by substitution method. Again, three methods we have. One, substitution method. Then we have elimination method. Elimination method, and one more we have, that is cross multiplication method. Cross multiplication method. Cross multiplication method. Right? So here let's solve this equation. Here we will go with elimination. Here either we can eliminate x or eliminate y. If you want to eliminate x, so first equation when so 1 is plus minus, multiply first equation by 6 and multiply second equation by 5. So here we will get 30y and 31. So first equation will become 18x plus 30y is equal to 72 and 10x minus of 30y is equal to minus 100. Now adding, this is equation number 3 and this is equation number 4. So what we are doing, adding 3 and 4, adding 3 with 4, adding 3 and 4, adding equation 3 and 4, what we get? It is get eliminated. 28x is equal to minus of 28. So what is x? X is equal to minus of 1. X is what? Minus of 1. Now, what is y? To find the value of y, we can substitute x minus 1 in any of the equation. Like here in second equation, 2x is minus of 1 minus 6y is equal to minus 20. So here, what is minus 6y? 6y is equal to minus 2 minus will get plus, right? So minus of y minus of 6y is equal to minus of 18. Minus will minus get cancelled. 6 ones are 6, 6 threes are 18. So y is equal to 3. So these are the solutions of the quadratic equations. X is minus 1 and y is 3. Here 3 upon 2 is not equal to minus 5 upon 6. Here we have discussed minus 3 upon 2. The ratio is not equal to 5 upon minus 6. Therefore, this is the unique solution. The point, that is the p minus 1 comma 3. These are the unique solutions, right? So this is the elimination method, simple one. Okay. So let's solve a few more. In your book here in AS level, they have discussed the intersection of graphically also they have solved, right? So H plus D substitution method also they are solving. So let's take few more solving of simultaneous equations, right? So here some exercise questions. Question number 1. It is having nine parts. Let's take one or two parts here. Question number 1. Equation is 2x plus 3y. 2x plus 3y is equal to 8. And here 3x plus 2y is equal to 7. Second, here I am taking the value 3u variable is in minus 2v is equal to 17 and 5u minus 3v is equal to 28. Two different variables are changed, and one is next we will do 4l minus 3m is equal to. So here we can go with substitution method. When we go with substitution here, because here when we multiply 2 and 3, 6 and 6 we get cancelled, right? Or if we are going with elimination, y with 2 and here with 3, so we will get 6, 6. So for multiplying first equation with 2 and second with 3, what we got? 2 2s are 4x plus 6y is equal to 16 and 9x plus 6y is equal to 21. Now what we can do? We can subtract one from another, minus, minus and minus. So get cancelled. We have left here with minus of 5x is equal to minus of 5, right? So minus 5 and minus 5 get cancelled. The value of x is 1. And if x is 1, put in any equation this value of x 1. Like here we have 2 into 1 plus 3y is equal to 8. 2x plus 3y is equal to 8. So what is 3y? 3y is equal to 8 minus 2, right? So what is y? Y is equal to 6 upon 3, y is 2. So the value of y, that is 2 here. Value of y is 2. This is the question solution of the x is 1, y is 2. In the same way, go for solving this question second, and you can write down in comment box what are the answers. So it is not only me that I should solve. Please, first equation is 3u minus 2v is equal to 70 and 5u minus 3v is equal to 28. Solve quickly. Let me take one more equation. That is let me take the last part. That is the equation is 4L. Equation is, this is the ninth part. 4L minus 3m is equal to 2 on 5L minus 7m is equal to 9. So solve here. Here also we can, I will multiply the first equation with 3 and second with, this is the equation number 1 and this is equation number 2. Multiply first equation by 3 and second equation by 2. What we got? We got the third equation. 3 3 is 9u minus 6 of v is equal to 51, and here 10u minus of 6v is equal to 56. Now this is equation number 3 and this is equation number 4. Now subtract one from another. When we subtract 3 from 4 or 4 from 3, this is minus, it will get plus, it will get minus, will get cancelled, and we have left here minus of u is equal to 56 minus 51, that is minus of 5. So minus and minus get cancelled. What is the value of u? U here in this case is 5. What is u? 5. And putting the value in any of the equation. Here, like 3u, that is 5 minus 2v is equal to 17. So what is this implies that 2v is equal to minus of 2v is equal to 17 minus 15, right? So v here is 2 upon minus v here is 2 upon 2, that is, so what is v? V is equal to minus of 1. These are the solution of the equation, right? So next one, that is, here we have the equations in terms of L and M. So let's solve it by substitution method. Substitution is also a very valid method to find the to solve the pair of linear equations, right? So here always substitute into the linear equation. Substituting in the quadratic will give you an extra answer and which are not correct. Okay, So here we are talking about non-linear simultaneous equations, right? Non-linear simultaneous equations. Also they are talking. So here let what is L? Here 4L is equal to 3 plus, and what is L? L is equal to 2 plus 3m divided by 4. This equation, this is from equation number 1, and this is equation number 2 here. So dividing, for putting the value 3 into, put equation 3, put or substitute equation 3 in equation 1, in equation 2, equation 3 here in equation 2. So equation 2 is 5L. In place of 5, L is 2 plus 3m divided by 4, right? Minus 7m is equal to 9. So here we will get the value of m here. We will get the value of m. So we have 10 plus 15m minus of 28m 4 is equal to 36, right? So here when we subtract, it is minus 12 and 15, so we have minus 13 here. Minus 13 of m is equal to 36 minus 10, so it is 26. So what is m? M is minus m is minus 2. So what is m here? So the value of m, so here what is the m? The positive value of m is equal to minus of 2. Now L, we are interested to find the value of L. L is 2 plus 3. What is L? We have already found in third equation L is equal to twice of 3 into m. M is minus 2 divided by 4. Right? So what is it? 6. What is it? L is equal to 2 minus 6 upon 4, which is equal to minus of 4 upon 4. So L is equal to minus 1. This L is, M is minus 2 and L is minus 1. These are the solutions of for L and M. Right? In this way we can solve some equations, right? By simultaneous equations, right? X square, here we have some other equations. So here we will write, we have some non-linear simultaneous equations, right? The simultaneous equations in the example so far have been linear. Now just go through, today we can take only these simultaneous equations, right? So already we have solved so many quadratic equations. These are all the simultaneous equations. From exercise we have some equations, quadratic formula, use the quadratic formula in these equations, right? So we have I have discussed earlier also how we have framed the quadratic formula, right? So a complete exercise that is based on the quadratic formula here, and graphs of the quadratic functions, that also we have discussed. Okay, and in detail we have in the beginning of the exercise you have to solve the following equations by factorization also, and let's take some of the equations, factorize, like here some questions, very basic questions. Here we have al plus am plus bl plus bm. Second, ur minus vr plus us minus vs, right? Minus of vs. Third, that is 6v square plus 3v minus 20v minus 10. And fourth one is q square minus 3q minus 3q plus 9. Factorize them. The very simple equations. Factorize them. So here the first one, see, a is common, right? So here what we have first, that is a common, a into l plus m, right? And plus b into that is again l plus m. So how we can represent? We can represent one is a plus b into l plus m, right? This is, we have to take common. Same here, r is this one here. R is common, R into U minus V, and again that here is S is common, and there is plus S common, and here U minus V, that can be written as R plus S and u minus v common, right? Like here, factorization. Now here, sixth one is 3v. We can take common 3v into 2v. 3v into 2v plus 1, and here again 10 we can take common, that is minus 10, 2v plus 1, right? So here what is left? We have left here 3v minus 10 into 2v plus 1. This is the factorization. 3v minus 10 into 2v, and here also same. We can take u outside, q into q, that is minus 3 right? And here again q minus 3. So here what we have to take minus of 3, minus of 3 outside, so it is minus of 3, minus minus will get plus. So this implies that what we have, one is q minus 3, or it is q minus 3, which is written as q minus 3 whole square, right? This is the factorization, right? This is the factorization. Let's take few more examples, okay, in which you have to multiply the terms. Question number 2. Question number 2. Again, there are so many parts. I will take only 3-4 parts. Multiply out the following expression and collect the like terms, right? So here also only question number 2. Two parts. First is, that is a plus 2, and then that is a plus 3. Second part you can take g minus 3g. One is g minus 3 g plus 3. Third one is h plus 5 whole square. Fourth part, a plus b into c plus d. So many parts, 10 parts are there. I am taking only 4 parts, right? So you can solve all the parts. These are very simple. So here we know, when we open the bracket, first one, this is a into a plus 3 and plus 2 into again a plus 3. I have opened the first bracket. So here we have a square plus 3a plus 2a plus 6. So which is equals to a square plus 5a plus 6, right? Here a minus b, a plus b, we know the formula, that is a square minus b square. A square, this is the direct formula we can apply, that is g square, and here minus 9. And in detail, if you want to do in the same way, when we open the first bracket, g plus 3 and then minus of 3, again g plus 3. When we open g square plus 3g minus of 3g minus of 9. So here 3g get cancelled, we have g square minus 9, a square minus b square. This is the identity we have studied in lower classes, like a plus b into a minus b is equal to a square minus b square. This is a square, this is b square, right? A square minus b square. In the same way, same identity, a square plus b square plus 2ab we can apply here. We have to want to apply the identity, you can apply the identity on here, that is h plus 5 into h plus 5. We have to write h into h plus 5 plus 5 into again h plus 5. So what we have h square plus 5h plus 5h plus 25. So here the final answer, that is h square plus 10h plus 25. Okay, or we can apply the formula also direct. A plus b whole square is equal to a square plus 2ab plus of b square, right? The last one, And the last one, that is a, when we multiply a with c plus b and then plus b again c plus b. So what is the answer? We have AC, we have AD, we have BC, we have BD. So nothing is common here. This is the simple answer, right? This is the answer here, AC. Now here only what are the common terms? C is common here and D is common here, right? So how we can write them? So same here. So here when we have this AC plus AD and BC plus BD, we can rearrange them. We can write here AC plus BC, and here we have that AD plus BD. What we can take? We can take C common. Again we have A plus B, and again, so it is again what will happen? We are going converse with B into A plus B. So what we have? That is again C plus B into A plus B. Again the same thing, right? This is the answer here. This is the answer here, right? So let's take few more questions. Factorize the following quadratic equation, right? Take few quadratic equations which we have to factorize. Question number 3 is there. Factorize the following quadratic expressions. Take few one. Question number 3. First one, that is your x square. X square plus 6x plus 8. Second one, let's take 3 or 4 parts. r square plus 2r, r square plus 2r minus 15. And next is s square minus 4s plus 4, and x square minus 5x minus 6, and a square minus 9. There are so many again 10 parts here. I have chosen only 5 parts, right? So go on factorizing. Here when we factorize x square, this x square middle term, that is 6x plus 8. So here 4 into 2. So here we can write x square plus 4x plus 2x, splitting middle term, right? 4 plus 2 is 6, and that is multiplied 8. So here what we can go ahead, same way, take common x into x plus 4. So here also we have to go over x plus 4. Here we have to take 2 common. So what is the factorization? Factorization is x plus 2 into x plus 4, right? First one. Same second one, r square. So 15, 3 and 5. We have the equation r square plus twice of r minus of 15. What will we do? Write r square plus, here we are taking 5r minus 3r minus 15, right? So here we have r into r plus 5 and again r plus 5. When we multiply here with 3, we'll get the term, and the factorization is r minus 3 into r plus 5, right? These are the two first thing. So go for the third one, right? So third one, is s square, s square minus of 4s plus 4. So here minus 2 s square minus of 2s minus of 2s plus 4. So what we can do, we can take s common, s minus 2, and again here s minus 2 here, and take minus 2 common. So what we have here s minus 2 into s minus 2, right? Or which we can written as s minus 2 whole square, right? S minus 2 whole square. Next, that is, before that, let me solve the last one first. A square, that is what? A square minus b square. So here a square minus b square, you can write down that a plus 3 into, right? And the fourth one, so fourth one is here 6 plus 1. Here x square minus of 5x can be written as minus of 6x plus x minus 6, right? So here we can start x into x minus 6, and here also x minus 6. So what is the common? Common is minus, not minus, it is plus 1. So we have here one is x plus 1, and here x minus 6, right? So dear students, this first chapter, that is the algebra one, is a very basic one, right? So this is all about today's class, right? You can go for these simple questions, right? So with this I am ending today's class, right? So God bless you, stay safe and stay healthy.